Today we are going to discuss radius of convergence calculation uh, for complex power series. Let's see for an example. Example 1. Find the radius of convergence of f of z is like that: sigma n from 0 to infinity z to the power n over factorial n. This is a series. So if we expand this series, then we can find 1 plus 1 over factorial 1 z plus 1 over factorial 2 z square and so on, and we can write 1 over factorial n z to the power n. Now we need to use the formula, the Cauchy's theorem of limit. There are two formulas. One is we can calculate the radius like 1 over r equal to limit n tends to infinity absolute value a1 1 over n. The another formula is 1 over r equal to the limit n tends to infinity a n plus 1 over a n. So these formula mostly used. We see in this series, or in this power series, we can see this power series, what is an? An is 1 over factorial n, and an plus 1 a1 n plus 1 is actually 1 over, we can write n plus 1, the factorial n plus 1. Now we use this formula, and we insert here, then we find 1 over r equal to limit n tends to infinity. We can put n plus 1 at first, the 1 factorial n plus 1, and multiplied factorial n over n, we can write. Then limit n tends to infinity, then we can write like this, factorial n, and this we can make 1 plus n over factorial 1 plus n plus 1 and the factorial n, and then we can see that these cancel, and then we find the result is 0. If it is 0, then the radius of convergence is infinity, and this means that the radius of convergence of this power series is infinity. So on the other hand, we can say that any value of z of this series will converge on a whole complex plane. Now we can see another example. Example number 2. We can see, for example, let's say to calculate the radius of convergence of a power series f of z is like that: n tends to n equal to 0 to infinity factorial n over n to the power n z to the power n. So using the same formula, we can see that what is an equal to we can see an equal to this is an, and that means factorial n over n to the power n, and n plus 1 we can write factorial n plus 1 over n plus 1 to the power n plus 1. Now we use this formula. In this formula, if we insert, then we find that 1 over r equal to limit n tends to infinity, and then we can have n plus 1. We can write n plus 1 over n plus 1 to the power n plus 1, and then multiplied. This will just opposite reciprocal n to the power n over factorial n. If we do some mathematical operations, then we can write this 1 over r equal to limit n tends to infinity a n, yes, we can write directly 1 plus 1 over n to the power n. So this actually, this is what, this is a, we can write, this is a e, exponential e. So that means n tends to infinity, we can write 1 over e, and 1 over e value is what? 1 over e is, actually we know the e, the value of e is 2.718. So in this way we can have this radius of convergence for f over z. So this is another example. So now we can write one more example. We can see one more example. Example number 3. Right? Let's say this is another complex series which is sigma n equal to 0 to infinity and 5 plus 12i to the power n z to the power n. So here we know that we can again define what is an. Here an is 5 plus 12i to the power n, and an plus 1 is 5 plus 12i to the power n plus 1. So the Cauchy's formula of radius of convergence, we can calculate limit n tends to infinity an plus 1 over an, absolute value. Then limit n tends to infinity, we can insert this 5 plus 12i to the power n plus 1 over yes, we can write an, we can write 5 plus 12i to the power n, yes, we can write. So if we cancel, then we will find that n tends to infinity, limit n tends to infinity, 5 plus 12i, this will remain. So this is the modulus in 5 square plus 12 square equal to 169 equal to 13. So we can say the radius of convergence of this power series is 1 over 13. Thank you very much.